Hello everyone, welcome back to Digital Lesson for Students by Department of School Education. I am T. Punguri, MSc MPhil Mathematics, your math tutor from City King Higher Secondary School, Jotsama, Kohima. In the last session, we learned the concepts of relation. In this session, we will learn some problems from your exercise. The first problem is, if x by 3 plus 1, y minus 2 by 3 is equal to 5 by 3, 1 by 3, find the values of x and y. Here it is given these two ordered pairs are equal. So, given x by 3 plus 1, y minus 2 by 3 is equal to 5 by 3, 1 by 3. So, we have already learned that if we say that the two ordered pairs are equal, the first coordinate will be equal to the first coordinate of the other ordered pair and the second will be equal to the second one, right? So, if you comparing the corresponding components, we get x by 3 plus 1 is equal to 5 by 3 and we have y minus 2 by 3 is equal to 1 by 3. So, in this case we get x by 3 equal to 5 by 3 minus 1. So, that is x by 3 equal to 5 minus 3 by 3. So, which gives us x equal to 2, right? And here y equal to 1 by 3 plus 2 by 3. This is y equal to 3 by 3, which gives us y equal to 1. So, this is how we get the values of x and y. Just we have to equate the components. Okay. Here is the next question. That is, let A is 1, 2, 3, 4 till 14 and define a relation R from A to A by R is the set of all x, y such that 3x minus y is 0, where x, y belongs to A. We have to take both x and y from A, this set, alright, and it should satisfy this relation. Only those ordered pairs we will take it here, x, y, okay, and write down its domain, codomain and range. Sometimes represent the relation in arrow diagram also, the question may be included. So, this usually comes for 4 mark. Here. So, what are the elements can come in? If you want to write A cross A, then finding out the relation, it's okay. But you just imagine we have 14 elements in set A, and then if you make the cross product 14 with 14, you will get 200 and something, right? So, you will get more number of ordered pairs. So, in that case, it consumes a lot of time. So, you can directly go with R. Writing R is the set of all x, y such that 3x minus y is equal to 0, where x, y belongs to A. Okay, which satisfies this relation, only we will take it here, right? Okay, so let me write this one as y equal to 3x. It's easy to calculate, right? And then R is, if you give 1 here, because it starts from 1 to 14, we have to give the values of x also from 1 to 14. At the same time, the y also should be included here 1 to 14, because x, y belongs to A. It should not exceed the set A, right? So, if you give x equal to 1, we get 3. So, 1, 3, right? And if you give 2, you get 6. If you give 3, x equal to 3, then you will get y equal to 9, right? Then, if you give x equal to 4, y equal to 12, then if you give 5, it becomes 15, y will be 15, but we don't have 15 here. So, we cannot take that 5 and 15. So, here afterwards it will more than 14. So, here itself we stop our relation R. So, these only 4 ordered pairs will be in the relation. Okay. Then let us write the domain. Domain is what? The set of all first coordinates of relation R. So, what are the first coordinates? 1, 2, 3, 4, right? And next one is codomain. Codomain is nothing but the set B. Set B is the second set. Second set which we take is also A, right? So, it will be 1, 2, 3 till 14. Okay. Then next range. Range is the set of all second coordinates of R. That is very important. So, what are the second coordinates? We have 3, 6, 9, 12. That's all. So, domain, codomain, range. If you find this, you will get 4 mark easily. So, I will move on to the next topic. The remaining exercise problems, if you learn the concept clearly, you can do by yourself. Since function is very important, more important than this all, so we will move on to this function. Function rules everywhere. It comes in trigonometry, calculus, probability, everywhere you can find this function. So you should know what is a function first of all. Function is nothing but a relation. It's a special kind of relation. It's a special kind of relation. See, between any two sets, we can define many number of relations. Among those, which one satisfies two special conditions? Only two conditions. The first one is every element, and the second word you should remember, unique image. If you remember these two, you can easily define function. Every element, unique image. So now let me write the definition of function. Let A and B be any two non-empty sets. Non-empty, we know it should have some elements. Non-empty sets. Then a relation. We are studying function, so I'll use F here. Relation F from set A to set B is called function. If every element of A has a unique image in set B. Okay, so every element, and this is unique image. These two words are very important. That means all the elements of set A, each and every element in set A should have an image in set B. That is function. So let me share an example which was discussed by my teacher with me. So it is easy for you to understand. If you take two sets, this is the set of all children, and this is mother or father. So we take women. So we take all the children in this set, and here we take all the women in this set. All right? Okay. So here there are many children, and here there are women. Every child will have a mother, right? The relation is mother. Every child will have a mother. And maybe more than one child, two child also will have the same mother, right? But they will have a mother. See, everyone will have a mother. Like this. No one will be left out. No one will be there without a mother, right? But there may be ladies who is not a mother of any child, right? We are not worrying about this, okay? But here, everyone is related here, yes or no? So everyone is related, and also they have only one mother. No two child will have the same mother. A child cannot have more than one mother, isn't it? See, this cannot be possible. A child, cannot have two mothers, yes or no? This is not possible. So it will have only one mother, therefore unique image. So this is a very good example to learn this function. Okay, so every element, every child has a unique mother. You can remember like this. Then you can easily define function. All right. Then function is like a machine. It's like a machine. So we give some input, say raw material, and we put it in the machine. We get some kind of output, isn't it? Output. So this is the function, and this is the x variables we give, and we get here fx or y. Okay, fx or y. So we can write this one as f is a function from a to b. This is the simple notation, function or mapping or map. Okay. So if you take an element x from a, this will be written as fx. X is from A, right? Then X goes inside this machine and it comes out as an element from B. So that is Fx. So we can write it as Y. Fx and Y same, but X is from the domain and Y is from the range. Y is belonging to the range. Okay, otherwise you can write this one as xy belongs to F. Xy belongs to F, or Fx equal to Y. So these input variables will be x and the output variables will look like fx or y. For example, if I define this fx as x plus 5, and here the x values I am giving 1, 2, 3. Okay, so what will be the y values or fx values? That is f of y equal to f of 1 will be, it is going inside and getting operated and coming out the result, right? So if you put 1 here, what do you get? 1 plus 5, 6. So 6 is the outcome. If you give 1 as the input and we get 6 as the output, the function is this one. Okay, it is working on this 1, 2, 3 and gives us 6. And then f of 2 will be 7 and f of 3 will be 8. Okay, 6, 7, 8 are the outputs, 1, 2, 3 are inputs. This one you can write it as y or f1, f2, f3. Don't get confused. Alright. Okay. So here the entire set A will be the domain. But in relation need not to be. Only the first coordinates will be the domain, right? But in function, every element of set A should be in the domain. So the domain of the function is nothing but the set A. It should be. If not, it is not a function. And codomain we know that is set B. And the range is the set of all second coordinates. Second coordinates of F. Okay. Otherwise, range is a subset of codomain. Please take note of this. The domain is input and the range is the output. This is x and this is y or fx. If you try to learn from the textbook, you will get puzzled. So please write down somewhere this like domain is nothing but input, that is x. So codomain is B. Range is the second coordinates of F. In short, no, you can write with your pencil in your textbook. Then it is easy for you to learn, because there will be a question in 4 mark every year. Find the domain and range of the function. Okay. So in that case, if you do not know the meaning of domain and the range, it is very difficult to solve that problem. In your textbook, we often come across these two words, that is real valued function and real function. Real valued function is the range is a subset of R or the capital R. See, here I have given a difference between this R and R. This, if you just write simply capital R, that is the relation. Alright. If it is in bold letter R, that represents the set of all real numbers. Okay. If the range is a subset of a real set of all real numbers or the set of all real numbers, then we call that function as a real valued function. That means the output which we get may be the set of all real numbers or its subset. Okay. But real function means the domain also real number or subset of R, and the range also real number or subset of R. Then we say that function as real function. Both are the set of all real numbers. Okay. And then graph, which we have studied in lower class. See, you have seen y equal to x plus 3 or 2x plus 3. Then how do you draw this graph? It is a linear function, so you will get a straight line in the graph, isn't it? Because the highest power is 1. Therefore, you will get the straight line in the graph when you draw this graph. So how do you do? You give x values, x is 1, then y is 2 plus 3, 5, right? Then you will make a table by plotting maybe 2 values. 1 if you give, then you get 5. If you give 2, then you will get 7. You mark this point in the graph 1, 5, and then 2, 7. Then you connect it, you will get a straight line. Yes or no? So then what about this 5 and 7? These are the values of y. Y is what? Fx. Okay, so the function we are representing it in the form of graph also. So the coordinates will be x, fx, which we are plotting in the graph. See, if you plot 1, 5, this 1 is x and this is f of, if x is, this is fx, otherwise you can write f of 1. When we give x equal to 1, you get 5. It can be represented as f of 1. f1 is nothing but 5, or you can represent y equal to 5. Okay, the y coordinate is nothing but fx. This is the function. Okay, there are some more special functions we will be learning in the next session. In these 4 arrow diagrams, let us find out which are functions. Is it a function? Yes, it is a function, because you see, every element of set A is mapped with some element of set B, isn't it? And also only once the arrow goes from every element. You see, only one line goes, right? Therefore, it is a set. It is a function. And what about this one? Is it a function? Yes. See, every element has an image and also only one line goes. Therefore, it is a function. And what about this one? It is not a function. You see carefully, because this is left out. This is left out. It has no image. Our definition is every element should have an image, but this is not having any image. Therefore, it is not a function. And what about this one? It is also not a function, because you see, from here there are 2 arrow goes out, isn't it? That means one has 2 images, A, B. If you write in the order pairs, you will write 1A, 1B. So this 1 comes twice as the first coordinate. No 2 ordered pairs should have the same first coordinate. Okay, in that case only we call it as function. But here it comes twice, therefore it is not a function. Okay, this is all the concept of functions. We will learn more in detail in the next session. Thank you.